Okay guys, welcome back to week 5 of our Arduino journey. So as promised last video, today we'll be going over a new type of LED which is an RGB LED. So I'll go over the design and how it works in a while, but let's have some art prelude over here. So basically we'll go over two types of colors first and then we'll get into the LED. So basically there's two types of colors, additive and subtractive. So additive colors work by adding lights of different wavelengths, and subtractive colors work by subtracting or absorbing light and then reflecting the rest. So we are actually going to be working with additive colors, which have primary colors as red, green and blue, which is RGB. So what additive colors do is that they start with darkness, which means black color, and then they add each RGB component, and that adds brightness to the screen. What subtractive colors do is they start with white, and then each pigment absorbs a portion of white light, which results in different colors forming. And the primary colors for subtractive colors are cyan, magenta and yellow. So as you can see, I have a differentiation chart over here, which is just basically what I read. So you guys can pause the video and go over that. Yeah, so basically what this RGB LED is going to be doing, it's going to be converting electrical energy into this light by adding wavelengths onto the black screen, which increases brightness. Okay, so now onto the RGB LED itself, we have 4 pins as you can see. Mine was labeled, but yours might not be. So let's just go over the pins first. We have red, green, blue, and G and D. So you guys might be thinking that since this is one LED and you okay, so we have 3 resistors over here. So what I was gonna say is that we actually will be needing all these three, because we should not think of this LED as a single LED, but rather 3 types of LEDs kind of like mushed into one. So that's why we need 3 individual resistors for each type, so that we don't short the LED. So just to see over here, this is a diagram of the RGB LED. This is how it usually looks like, but this is not how mine looks like. So we have the red, green and blue, which are going on top to their own individual light, whatever LED type things, and reflecting the light. And then we have one GND. So we have a lot of new code to learn today. So before we do that, I'll just make a circuit with the RGB LED, and then we'll go to the IDE and then do the rest. So as usual, we're just going to connect this like any other normal circuit, but like I said, we don't need just one resistor, we need 3. So I'll connect the circuit and then just explain it to you guys one more time. Yeah, so my resistors have gone a little haywire, so it is getting harder and harder every video to kind of put these in. Okay, so I'm done with the circuit. I'll just show you guys. So, like I said, I hope you can see what I've done here. Like I said, we have to connect one resistor for each of the LEDs. So we have RGB, and I've connected one individual resistor for each of those. Then connected that to a wire going into the pins of the Arduino, and then one directly connected to GND, because as we obviously we don't need a resistor for the GND. So yeah, I'll see you guys with the IDE and let's learn some new code. Okay, so what we'll do first is just try to make our LED just show any color, and then what we'll do is we'll try to make something that lets us choose the color that we put, not just like have it be previously decided. So I'll just give all the different LEDs a pin value first. So I've put these in 11, 9, and 6. Okay, so basically how RGB values work is, so this is not a command, but just to show you guys how it works. So RGB values work in the sense that it goes R first, then G first, then the blue value. So you can just go on Google and search. So I'll just do that in front of you guys. So you can just go on Google and just search RGB value for any color you want. Sorry, I don't know why my browser keeps switching to Yahoo. But yeah, so basically every color on the planet has a designated RGB value, and you can just find that out from Google or whatever. So now what we'll do is we'll try to use the RGB value for pink, and then we'll try to make our Arduino just basically reflect that. So let's go and declare the modes for all our pins. Yeah. So now in the loop section, all we have to do is just assign the RGB value. So RGB value is like, any other bitrate, goes from 0 to 255. That's given on the RGB section. So just uh, use analog, right? And keep in mind that we're using the pulse width modulation pins. So we need to use analog, right? Which is what I'm using. So analog, right? And then red pin, comma, whatever value you have for red. So for pink, we have 255 here. So I'll just do that. Analog, right, blue pin, and 182, and 193. Okay, so this is these are the values for basically our pink color. So this time I won't, keep switching between the ID and the physical cam. I'll just try to attach, hopefully that works for me. So I'll just try to attach a video of it side by side. So I'll just upload the code, and yeah, we can actually see it working. Doesn't really look like pink, so I'm not sure what color codes I'm using, But yeah, there is some color, which means, and it's not like the obvious red, green, or blue. And that kind of does look like pink if you look at it from the right angle. Yeah, so basically that's how it works. Now let's try to make something that takes our input as to what color we want, and then just prints that color out. So okay, for that we'll need to learn two more commands. So first, we'll start with the basic one. So okay. So if you guys are familiar with any other programming language, we have conditional statements. So that's just what we're going to be using. So in C++, how it works is you have your if conditional, and then so how it works is you write if, and then in these normal brackets, you write whatever your condition is, and then in the curly braces, you want to write what will happen if your condition is true. Okay. So that's one thing. And then we'll learn another command called serial dot read string. So what this does is this allows us to use our serial monitor, enter an input there, and that will just read that basically, and then the Arduino will be able to tell what we communicated with it using the serial monitor. Great. So we have these two new things, and you guys might have guessed where we're going with this. So let's just do that. So a few modifications. We'll just declare a string variable and just keep it here. So we'll do color val, which stands for color value. Now, when we're declaring string variables, it's slightly different than int. See, you have to declare it with the first S capital, unlike other variable forms. So yeah, let's just do that. Then declare our baud rate as usual. Serial dot begin 9600. Great. And now we'll actually write an if conditional that if okay, so we'll use we need to write an if conditional to find out if what we've inputted is, suppose if I'm inputting a color. This is my input, and we have to check if that is equal to a designated value that we're going to set here. So pink. And these are the values for pink. So we need to check if what I've inputted is equal to pink or whatever pre-designated color we're keeping over here. So that then we can use analog write to display that color. Okay. So for that, we need to first, we've just declared an empty variable. So for that, we need to first give our color val a value that we'll give. So color val is equal to string, sorry, serial dot read string. So what this will do is basically once we communicate with the serial monitor, whatever we want as our color to be in the color val, that'll just assign color val that value. Okay, so that's that. And then we need to check if color val is equal to pink. Now, if you're new with programming in general, you might have noticed that I've used two equal tos instead of one. So in most programming languages, there's two types of equal to operators. So if you use one equal to, that means you're assigning something to another thing. So one equal to, what that means is that it's assigning a value from right to left. So it's assigning the value of, sorry, left to right then. No, I don't know, maybe it's right to left, but whatever. So basically, if there's one equal to, it's assigning green pin the value of 6. So I don't know if that's left to right, right to left, whatever you want to call it. So it's an assignment operator. but it doesn't actually mean equal to. So to actually make it mean equal to, we use two back-to-back equal tos, and then that will check if the value for color val is pink. Now we can't just leave it as pink here, and that will uh, not actually help us do anything. It will give it the wrong answer. And even though logically this statement is completely correct, we'll need to add something over here, which is backslash n. Why we need to do that is because serial.readString, just like as a command, it accepts the value and then reads it and then prints it on a new line. So there will be a new line printed. So if we don't add this backslash n, what will happen is uh, what color val will actually be. So if we enter pink, color val will actually, so if we enter pink, color val will actually store it as pink and then like another line, an empty line, because that's just how it stores stuff. So for C++, we just need to add this backslash n to signify that there's going to be another empty line that's going to be stored in that variable. So just to account for that, we need uh, pink and backslash n. And then going along with the if conditional, we have uh, else if and else. So first we'll go over else if. It's basically like options for if. So you can give options. So it's either, so if color val is equal to pink, do that, or elif else if, sorry, not elif. In Python it's elif, so slightly confusing. Elif color val is equal to red, then we can add the specifications for red. So just like that. And you don't need to use this, but it's just there. And then there is else. So if doesn't work, as in if doesn't work, else if doesn't work, then it directly skips to the else block. You don't need brackets for this. Just directly tell if all of those previous conditions don't work, what do you want in your else bracket, and that'll just run. So how it works is you go through, it loops through all this and it goes through the conditionals and it goes through each of them. And if it doesn't work, if the condition is not true, it just skips over it. Nothing will happen. It will just skip over it. Okay. So in our else section, we're just going to write serial.print color not recognized. Okay. Great. So let me just check over this, but I feel like it should run. Color val is equal to, forgot the backslash, n. Yeah, and sorry, this has to be like kind of indented into the if thing or it won't work. I don't know why that is. It's not like that in Python, but it is just something that this language has. So we'll go with it. Okay, let's verify. Oh, forgot the A. Right, so I know what the problem is. Oh, I just indented it twice. Sorry, I don't understand what the problem is. Oh, I never opened the bracket for if. Lol. Let me just copy all this stuff inside. Oh, it's quite annoying. Okay, let's try this. Hopefully this works. Oh, lovely. There's another error. I know what that is. Yeah, that is what I did right. I don't know what the problem is. What the hell is the problem? At the end of input. I'm sure the whatever the problem is, it's visible to you guys, and I'm just. And we don't have to even use this, but I do really want to show what happens. So this video might be slightly longer. Just skip ahead. If right. So I have no idea what the problem is here. Let's just write it like this. How about that? Oh God, what's the problem, bro? The end of input. So this is taking too long. I might just have to cut the video, figure it out, and then get back to you guys. Okay, right. So, do you know how that bracket got whatever misplaced? So yeah, okay, works now. Uh, I'll just as I input this, compile this code, I'll have a live feed of the what's going on with the Arduino. Okay, so verified it. I pressed in the Arduino. So it's already shining, the Arduino. That's because of the previous code that we uploaded. So once I upload this, it should be different. Okay, turned off. We go here, type pink. Yeah, shining again. And then right after that, okay, you see color not recognized. Now, if you have common sense, you should be able to recognize that this is a looped code. So we typed it once, it did its thing, and then it's going over again and again. And since we're not continuously typing ping, ping, ping at 255 bits per second, that's what's happening. So it just goes to the else code and prints color not recognized infinitely until we stop it. Great. So this is a very long video, partly because of that stupid mistake I made. Yeah, but that's it for this. This is very interesting to me because we're gonna do some very cool stuff with this RGB LED. So I'll see you guys with that.